Hello, and welcome back to Kerbal Space Program. We're going to jump back into our example game, and today I'm going to go over some of the finer points of spacecraft design. We're just going to be going over a lot of the different parts in the VAB and their purpose. So here we are back again in the uh, Vertical Assembly Building. That's what VAB stands for, and we're going to design just a little example ship. In fact, let's name it that, example ship. I apologize if the sounds of me using my keyboard are kind of loud. My microphone is very near my keyboard just to try and be a little closer to my mouth than on the top of my laptop hinge, but hopefully this all works out for you. Okay, so here we are again choosing our command module. And I'm just going to go over each one, let you know what they are, what their best use is, some of their advantages or disadvantages. So first is the Mark 1 cockpit. This is for space planes. Really the only thing notable about it is that it does not have a connector on the front. You can't attach a nose cone to it or the avionics package, which is one of the parts I'll show you in a bit. The Mark II cockpit is similar, except that it is not quite as aerodynamic, although it does have less drag, interestingly. But it does have that front node connector, so we can attach an avionics package or whatever else we might want. The Mark III cockpit is designed more specifically for space planes, and it has a larger crew, as well as having the back is shaped as a Mark III sized body, which is much larger than these Mark I sized bodies. So those three are space plane parts. They're cockpits. Next we have command pods. The Mark 1-2 command pod is a 3-crew size 2 command pod. It's good for long-term missions where you need a larger body diameter just to hold more fuel. The command pod Mark 1 is much the same. Well, no, I take it back. It's nothing the same. It only has one crew and is a size 1 adapter on the bottom and a small size adapter on the top. Mark II lander can is a 2-crew size 2 pod. The only difference really between the other pods and this one is that this one does not have a taper. It's a size 2 connector on both ends, commonly used for landers, as the name implies. These three are just from some plugins I have. I'm not going to go over them. They're very special mechanical jet items that basically give you more autopilot functions than SAS provides. Same with that. These three are probe cores. These two have probe size adapters on the top and bottom, whereas this one only has one on the bottom. These you can also attach items to the different sides, whereas this one you cannot. This is more, as the name implies, of a Sputnik style item. So we're going to go with a pretty generic command pod Mark 1, and actually, you know what, let's go with Mark 1-2 command pod. So like I said, it has the size 1 adapter on the front, as you can see here, and the size 2 adapter on the bottom. And this is going to allow us to do a couple different things. The first thing we're going to do is we want to be able to slow down upon a re-entry. So, in the utility tab, we're going to grab a Mark 16 XL parachute. And this is going to be our final stage. This is going to be all there is left when we come down from our orbit. We don't need anything else, as it is a crewed pod. We do not need, by crewed I mean it has crew within it, so it's 3 crew. We aren't going to need to have a lot of batteries, because if the power runs out, we still have a crew, we're pretty fine. Whereas with the probe cores, they use a lot more electricity, so you generally need to have some batteries. So quickly, let's go over a few of these parts before we add any more items to our pod. The fuel duct allows you to transfer fuel from one fuel tank to another in the direction that you place it. So for example, if I have a fuel tank and then another fuel tank, attached to the side, say like this, and I want this fuel tank to be able to draw from these, say I don't put a rocket on these, they're just extra fuel, I can take these fuel ducts and attach them first to this external tank and then to the main tank. And as you can see from the arrows here, the fuel is going to flow from this tank to this tank. Here we have a couple different size fuel tanks. First we have the half-length, I like to call it, the half-length 1M size tank, the half-length 2M size tank, the quarter-length 2M size tank, the full-sized 2M tank, and the 1/8 size 2M tank, and finally the quarter size 1M tank, and then the full 1M tank, of course. This is a jet engine. This is used for space planes upon re-entry. They don't work in space, they need air, and they don't need oxidizer. A couple different engines. This is the raw basic engine. It's a 1M size engine, as you can see here. It does not have thrust vectoring. This is the main sail engine. It's the largest engine in the game. It uses a lot of fuel, but it also has a lot of thrust. It's not very fuel efficient, however. It does thrust vector as well. This is the thrust vectoring version of that first engine. Only slightly lower engine power. The Poodle engine, not very powerful, but relatively, well, it's not very fuel efficient. It's actually less fuel efficient than the main sail engine. I honestly don't know what you would use this for. Again, it also has thrust vectoring. The LV909 engine, this is useful for landers. It is very fuel efficient, but it's not very powerful at all. As you can see, its max power is only 50. I mean, that's a quarter of the 1M thrust vectoring engine. It does have thrust vectoring, not very much, but it's used primarily for landers, so it's, I would say you wouldn't be going fast when you're using this, so thrust vectoring isn't really, you don't need a lot. The LV1 liquid fuel engine. This is a very small engine, as you can see here. It has a thrust of 1.5, and it does not thrust vector. I have never used this engine, and I probably never will, unless they add much smaller craft than they currently have. An engine this small, even on a probe, is almost entirely useless, as your thrust-weight ratio is going to be too low to effectively do anything. And it's also not very fuel efficient. We have a couple probe-size fuel tanks, as you can see here. They don't hold much, but they're useful if you're going to have a probe try and land somewhere and you need to be able to slow down. You can use that and a smaller engine. Mark 1 fuselage is used by spaceplanes and jets. They do not carry any oxidizer, so you can't use them with standard engines. You have to use them with the jet engines. Therefore, they're not really useful unless you plan on having a re-entry vehicle that has jet engines. It's about the size of a 1M connector. The Mark II fuselage is a bit bigger, but thin. It's, again, designed for spaceplanes, only holds liquid fuel. There's the Mark II to size 1 adapter. It holds a bit of fuel, which is why it's under the propulsion instead of the structural tab. Mark III fuselage, again, just more parts for spaceplanes. They all hold fuel, completely useless for normal spacecraft. I'm going to skip these two parts because, again, they're from Mechanical Jeb. The LVN atomic rocket motor. This is an extremely efficient motor in space, but in the atmosphere it's almost entirely useless. It has a very low power, 60, but its fuel efficiency means that it's going to last you for a long time. This is good for long hauls where it doesn't really matter, you know, having a long time to burn. You can, you know, do your burn over several minutes instead of several seconds. Yeah. It's also very large and very heavy, so it's really only useful in space. You've got some radial mount engines. These attach to the outsides of things. This one is the thrust vectoring version with a max power of 120, and this one is, well, this one's also thrust vectoring, but it's got a smaller power of 20. This is useful for probes, I find. This is a radial mount monopropellant tank. This is for your RCS. It's just for maneuvering. They're useful if you don't have really room or you don't need that much RCS fuel, instead of using these 1M and 2M RCS tanks. The Separaton is a fun little item. It is basically a very, very small solid rocket. It's primarily used for getting you away from your debris when you separate a stage, so you don't collide by accident. Very useful, very useful. They got about a 3-second burn time though, so don't use them for anything useful. Very small power as well, 20. And just a note about solid rockets, you cannot control their thrust. They're just a constant burn at 100%. We went over the Rocket Max 2477. This is the medium-sized solid rocket booster, with Separaton being a small size, and this is the large-sized solid rocket booster. This is about a 43-second burn time, and I believe these are around 17 seconds. This is the Aerospike rocket. Again, a very fuel-efficient rocket. Not a lot of thrust, but it's got almost the same efficiency in space as it does on Earth. So they're useful for situations in which you have a very light ship and not a lot of fuel, that you want to be able to go in and out of an atmosphere without having to worry too much about wasting fuel. Our smallest, well, maybe not the smallest, but one of the smaller fuel holders. This is primarily, again, for satellites. And then finally the turbojet engine. This is a high altitude, high power jet engine. As you can see, it's got a pretty high, basically the higher into space you get, the more efficient it is, and it's pretty powerful as well. However, as you get higher, it's harder and harder to collect the intake air required. So a very tricky engine to use to get a very efficient altitude. So that's everything in the propulsion tab. For now, we're not going to stick anything on until we've gone through most of the other parts. Again, SAS and Advanced SAS. I explained these in the last video. And the Avonics package, which attached to the front of the Mark II cockpits and the Mark III cockpits. It's similar to standard SAS, which is basically ASAS without the rotational stabilization. It doesn't stabilize your yaw, I believe. We've also got RCS thruster blocks. These are 4-directional, laterally mounted thruster blocks, as well as the RCS port, which is unidirectional outwards from where you are placing it. You can also rotate them using the W, A, S, and D keys. I don't know why you would, though. Just use one of these. Alright. Just a note about RCS, regardless of where you place them, they will automatically thrust in the most efficient direction based on their location and orientation in regards to the center of gravity. So no matter where you place it, if you RCS, give it some RCS yaw, it's not going to they're not all going to thrust in one direction. They'll thrust in the direction most appropriate for their leverage point. Some more mechanical jet parts, ignore them. Structural, Rockmex brand decouplers in sizes large, medium, and small. We've got an adapter from size 2 to size 1. That is literally all it does. And a more compact adapter from size 2 to size 1. We have launch stability enhancers. These attach to the side of your craft and are clamped to the bottom of the launch pad. So they hold your ship in place until you activate them, at which time they release and activate whatever. So, for example, you could activate your engines, throttle up to 100%, and then release them, and off you go. And actually, if I launched this right now, I believe, since we have the parachute and the stability enhancers in the same stage, we should just parachute safely to the ground. Let's test this theory out, though. Bear with me. Okay, so as you can see, we have some crew. I should probably turn my UI font up a bit, because I can't read those. It looks like Thomsby, Dongle, and Carberry, or something along those lines. Alright, so if we release all of our stages at once right now, yes, we get a parachute test. Excellent. Actually, well, I've already ended the flight. Just as a note, you can, once you've landed, you can EVA, and if you can get your Kerbal close enough to those parachutes, you can actually repack them, which is very interesting. We're going to go back to the vehicle assembly building right now, though, because obviously this is no craft worth flying. I just wanted to see if the parachute would deploy at that low an altitude. Okay. So that's the launch stability enhancers. Very useful things. Back to the structural tab. We have structural fuselage. This is a spaceplane fuselage. Does not hold fuel. Is stronger and lighter. That's really about it. Mechanical jet part. NCS adapter. This just goes from the Mark III size to a nose cone size. It's basically a size, a 1M to a nose cone size adapter, I believe. Radial decouplers. Alright, so for these I'm going to need some staging parts to really illustrate what they're for. So let's put on a... Oops, I don't want an advanced SAS. I want a decoupler. And I want some fuel. So let's just stick on something good here. let's do this. And have a very small stage here with our most efficient engine, the atomic rocket motor. Do I want to do that? Do I? No, I don't want to do that. I don't want to do that at all, as a matter of fact. As a matter of fact, what I want to do is I want to put on this and make a small little lander out of this. Okay. So back to the structural tab. The decouplers, which includes the TT38K radial decoupler, the hydraulic detachment manifold, and the radial decoupler. These two are small size decouplers, like so. And this is a much larger decoupler meant for attaching to 3M parts, though it doesn't really matter. They just have different strength tolerance. No, they all have the same strength tolerance. This one's just heavier. So I guess it really doesn't matter. What these do is they attach something to your ship in such a way as to... Let's just try and do that. In such a way as to allow items to be attached to the sides and be detached eventually. And this particular one, this one here, allows us to also set it a distance apart from the rest of the ship. So we're going to use those. We're also, I think maybe we'll use some hard points. They're similar, except you can't detach them. They just let you hold something out a distance. That's literally all they do. Yeah. Maybe... Yeah, okay. We've got tricouplers. These are, well, they're exactly what they sound like. It's just a 1 to 3, 1M adapter. There's also a bicoupler that is also what it sounds like. A 1 to 2, 1M adapter. Stack separators are like decouplers, except they don't stick to one end. So when this decouples, it'll stick to everything here. Whereas if I had one of these stack separators, it would float away as a separate part. Multi-point connectors, these are useful for space stations. They just let you attach things in 8 directions, or sorry, 6 directions, goodness, with my geometry. Structural pylons, these are like the hard points but larger. Strut connectors, they let you attach one thing to another and provide structure. They're useful if you have wobble or you don't want certain parts colliding with each other. You can ensure that they're reinforced with these. And then struts, they're just useful for, you know, if we want to put engines like far out on the cells like this, we could. We're not going to though. Okay, so some basic design. Let's see, what do we do here? I know we definitely don't want that. So if we attach these, this is going to be like the worst rocket I've ever designed, just for the record. The title in this video, Advanced Rocket Design, does not mean this is going to be advanced rocket. I'm just going over advanced concepts in rocket design. Right now I'm just going over parts. This is just an example. We'll probably get to an actual well-designed lander in a bit. But for right now, I'm just going to throw on parts and see if I can get this to work. Aerodynamic tab, lots of fins and stuff. Those are mostly for space planes, although it is useful to use these AVR8 winglets if you're going to try and maneuver within an atmosphere. However, since this is a lander, I'm not going to stick any on, since we're mostly going to be moving laterally, not vertically. Utility includes all sorts of things, such as landing struts. heavy-duty landing struts, which we're going to stick on. Solar panels, parachutes, thermoelectric generators, more parachutes, just really anything you might really need. So I'm just going to throw a couple of these things on that are going to be important to us. Yeah. Oh my, it doesn't reach the ground. But if I do something like this, then can we? I wonder. This is a good question. So let's do something like this, where we try and fudge this up a lot. I don't know if this is gonna work, people. I'm just kind of making it up as I go. Oh goodness, and I just realized I've got symmetry on for all of these things, so... Oh goodness. There we go, okay. Okay. Science tab just includes some instruments and communitrons. These really aren't implemented in the game yet, the communitrons. And the instruments are useful, but they don't really tell you a lot. You know, they tell you the temperature and the air pressure and stuff. But since none of that really matters yet, except maybe air pressure, we're not really in any trouble. As well as accelerometer, I guess that's pretty important. As well as, alright, so the thermometer is not terribly important, but everything else pretty much is. Alright, this is an interesting craft. An interesting thing to note is the Action Groups tab. These are linked to some of the buttons in the flight mode as well as the custom action buttons. So for example, if we want to link the gear button to our landing legs, we can just, whenever we press this, it'll toggle the legs. So that's useful. We can also have a custom, the lights automatically, if we add lights, they automatically go in, don't worry about those. If you want to do a custom though, and these are activated by pressing Alt 1 through 0 on your keyboard, we'll activate 1 through 10 here. If we want to activate, say, our ladders here from Alt 1, we can do that. Alright, so that's just all the basic parts. This thing is never going to fly. These engines are just too small for it. But let's see what happens. You never know. Never know. Bear with me here, older computer. I'm running on a lot of low settings. I don't necessarily have to, but with Fraps recording this, it's handy just to keep a steady frame rate up. But normally I could run medium settings without a trouble. This whole setup doesn't really make any sense. Ideally, I would have put fuel connectors between these two so that we could actually separate this and have fuel left in here so it would make sense, but we didn't, so. Okay, so pressing the gear button here will toggle the legs down, which is what we want. Perfect. And where did we stick all that stuff? Okay, it's right there. Pressing Alt 1. Perfect. Will that reach the ground? Ooh, not quite. I may have to jump. Alright, let's see if Thomsby Kermit will EVA for us. Oh my. I don't know if they can ladder sideways. No. So what if I... Oh Oh. And it looks like he also can't really reach this. Wait for it. Oh, I almost had it. There we go, okay. So now we're going up. Going up. And, oh, okay. Well, okay. So, oh, forgot to set up the staging. You can edit your staging on the fly here. Not that it's important, I guess. It helps on occasion if you make a mistake in the VAB, you can rectify it here. It actually does lift off. Barely, whatever spot with just one engine. Also going very straight up. As you can see, these engines are pretty fuel efficient. It's not really used at all. Manually shut off the engines here. And deploy our parachutes. Perfect. Now we could always do this. Cool, alright. I'm not sure. Sounds like it crashed into the ground now. Alright, that's a terrible example of everything. Don't build them like that. That's a terrible ship. In fact, it's so terrible that we're going to scrap it entirely. And let me just quickly build a decent lander here. I'm going to use Command Pod Mark 1 because it's a proper size for such things. One man, etc., etc. I'm going to stick on the smallest parachute here on the top. And we're going to use the 1M stacked coupler. I'm going to stick a relatively small amount of fuel underneath it. Yeah, there's about half. Like I said, relatively small amount of fuel, because we want to properly be able to, yeah, you'll figure it out, don't worry. Got some radial decouplers in here. Okay. We'll stick a little more fuel on these. And we're going to link them, like so. So now the fuel is going to draw from here first. Structurally, we don't necessarily need to do this, but I'm going to anyways. I'm just going to reinforce that connection there, so there's no wobble. And let's have some parachutes here. Some landing legs. Actually, let's not have those parachutes. Let's have these parachutes sort of there. And instead of those top parachutes, you can have some illuminators, which you can oops. There we go. Sometimes it can be hard to get these lined up perfectly. Alright, oh, what have I selected? No, this engine, okay. So that should be a decent lander there, actually, all on its own. We do want motor control though, so let's stick a advanced SAS module underneath this final stage. Perfect. Some stairs. And finally, full and proper stairs. That should take us to the bottom. Actually, don't need these legs, we need these legs. Because they're a bit short. Stick these as low as possible. Alright. Oops. The symmetry on these wrong. Alright. That should work for us. Let's just build a quick and ready stage underneath it. Just to get it up in the air. Alright, and pretend we have, you know, full staging system down here that'll get us into orbit, etc. To another planet, perhaps, or the moon. Alright. So we want those 3 engines, yes. Actually, we want all the engines. We want that to be a separate stage. Okay. That to activate there. These to activate here. And we'll, for the heck of it, put in some separatrons. Like so. And they will, oh perfect, they'll go in there. As will these. Alright. This is a much better designed lander than before, as you can see. We'll just stick the gear in there. And we might as well stick this custom. Okay. Let's name this Lander. Save it and launch. Oh, Thomsby is still on the launch pad. Let's get him out of there. I'm surprised he survived being underneath a engine when it ignited. That's not a feat many Kermans can claim to. Ooh, we're starting to run on 30 minutes here, so get this done quickly. By default, the gear is toggled on, so the first time you click it, it turns them off, and since they're already off, they don't do anything, so don't get freaked out that they're not doing anything. Let's just lock our heading, full thrust ahead, and launch. Now you want to throttle back quite a bit, because this low in altitude, we don't want to exceed 120 meters per second or so. You'll just waste most of your fuel on air resistance. You don't want to do that. So let's just lay waste to this tank of fuel here and then see what happens. Throwing down even more here. So much power in these engines, but as you can see, we're already halfway through our tank of fuel, so not very useful, perhaps. One thing interesting to note, the lights do not use electricity, which I find strange, but is the truth. Let's just burn through this last bit of fuel. Going pretty fast. Right now, normally we would start our gravity turn, but okay. SAS really has no way to control us right now, so we're sort of just spinning out of control. Normally we'd be on the descent right about now, so I'm going to, well, once we start our descent, we currently have an apoapsis of 16 kilometers. And right about now, we should start coming around. Bingo. Okay, now we're heading down. And we're coming down over the ocean. So, let's just do this. Let's try to bring that back. Ooh. There we go. Back. Oh, goodness. Ignore that. Windows 8 notifications. Pardon that. Let's just thrust in that direction for a bit. Try and bring us down over the land. Alright. Let's bring us back to vertical. And lock on there. Wonderful, okay. Right about now, we should probably lower the gear, and once we reach about 5 kilometers, I will deploy the next stage, which is some of our parachutes. 2, 1, 0, pop. And that should slow us down further. Parachutes alone probably won't get us to a slow enough speed to not break off our landing legs, so we are going to have to probably use up a decent amount of our fuel. So as you can see, we've used up fuel from these outer tanks, but not from the inner tank, which is because of those fuel connectors. So we will continue down like this until about 500 meters, at which point we will deploy our parachutes. And as you can see, we're going 10 meters per second, which is probably not slow enough to hold with these small landing legs. I'd prefer to slow down to about half a meter, ideally, but that's not necessary, as our chutes will detach by that point. So let's just get down towards the ground here, and at this point it can be useful to do a IVA, because you do get a radio altimeter. 7, 6, 5, 4, that's not very handy right now. Alright, so we're down. Beautiful. Alright, and what we're going to do now is, well, we'll simulate relaunching from the surface of the moon, for example. by deploying our next stage, which will ignite all of these retro rockets and decouple those. So let's try that out. And we have liftoff. Now this would be more than enough thrust normally to get us, off the surface of the moon, for example. But right now it's not really going to, so I'm just going to cut and launch parachutes in a moment. And run out. And we can watch that stage just crash and burn. Ooh. Maybe we can't watch it crash and burn. Oh, there it goes. And we will float safely to the ground. If I just warp back a little bit here. One more. And again, we've got this radio altimeter here, and we're down. So, alright. Well, how did that survive the fall? Strange physics in this game. Alright. That's about it for our advanced spaceship building tutorial. I'll probably have more later on rockets to get us into orbit, and rockets to get us to the moon, and then maybe rockets to get us outside the solar system. But that will be in future weeks. So enjoy this video. I hope you liked it. Just give me a thumbs up, maybe a sub, and we'll see what else we can do. Later.